last couple of videos we've talked about the notion of the derivative. And in the last video in particular we looked at the graph of a function and using that to come up with the graph of the derivative. And basically what we showed is that if I have a function and I take the derivative of that, it is also a function. Okay? And so we can use that idea to define higher order derivatives. So if f of x is a function, then we know that f prime exists, and in particular f prime of x is a function. We call that the first order derivative. Okay? So likewise, if I think of that as a function, the derivative of that should exist. And so f double prime, or the derivative of f prime, is a function. This is what we'd consider the second order derivative. Okay? And we can do it again. If f double prime exists, then there is a derivative of that, and so f triple prime would exist and is also a function. And this is our third order derivative. And we can keep going with this. For some functions, there are infinitely many derivatives. We can think as long as it's a function, we can keep going. Other functions, the derivatives start to become all the same after a certain point. And for most of the functions that we're going to look at in this beginning chapter, meaning chapter 2, we're going to see that this notion of a higher order derivative is eventually going to reduce down to 0. In later chapters we will see that if we start looking at higher order derivatives, they don't necessarily go to 0, and it's just because of the nature of the function. Okay? So let's look at an example. If f of x is 4x squared minus x plus 3, let's find the first three derivatives. So let's find the first order, the second order, and the third order derivative. Okay? So for f prime, meaning our first order, we know this is going to be the limit as h goes to 0, 4x squared minus x plus 3. We need that with an h in there for x plus h squared minus an x plus h plus 3. That minus the original 4x squared minus x plus 3. Whole thing divided by h. Now again, we've seen the polynomial ones before, and the idea again is to FOIL them out and simplify down. And so here when we FOIL out and simplify, we're going to see an 8xh plus 4h squared minus h all over h, which we can simplify to an 8x plus 4h minus 1. And taking the limit, we can see we're going to get an 8x minus 1. Okay. So there's that first derivative. Okay. That again we're going to think of as f prime of x. So again, looking at that, that is a function, so we should be able to find a second derivative. Which means, again, all I'm going to do is take the derivative of this function to get this function. Okay? So we'll do the same thing. Limit as h goes to 0, 8x plus h minus 1. That minus the function 8x minus 1 all over h. Okay? Still a polynomial, still simplifying down, just not as much foiling. So we can see limit as h goes to 0 of the first part, so the 8x's will cancel. We'll get an 8h minus 1 plus 1 will go away, so over h. Notice here those h's cancel directly, limit as a constant, so f double prime is just going to equal 8. And again, we want to be able to find the third derivative. So again, f double prime equaling 8, that is a function. So to get the third order derivative, we're going to take the limit as h goes to 0 of our function at x plus h, which just happens to be a constant, minus the function all over h. And so this one's really nice, because we can see that that's just going to go to 0, and the limit as h goes to 0 of 0 is just 0. And so this is what we mean by, at some point, some of them may kind of start becoming the same thing, or they might cancel out to be the same thing. Because now if we look, f triple prime of x equaling 0 is a function. If I wanted, I could go more than 3 derivatives, right? But notice that every derivative after this is also going to be 0, because once I do my f of x plus h minus f of x, I'm getting 0 minus 0. And that's going to be true for all of my derivatives after this point. So, like I said, for polynomials, the nice thing about these is at some point the derivative is going to go to 0, or some higher order derivative is going to go to 0. But we can use the notion of the derivative at every step, because we are still looking at a function.